Okay, perfect. My name is Zakria, and today I'm going to present just like a short discussion about pre and post bushfire disaster assessments using artificial intelligence and different meta-heuristic based algorithms. Starting with a brief introduction about myself. Currently, I'm a postdoc research associate at AI Institute within the UNSW Sydney campus, and this is the main title of my presentation today. Starting with the bushfire, just like what basically initiated this research was just like the main highlights from 1965 till 2020. That was a recent Black Summer bushfire event that happened in New South Wales. Just like letting you guys know, New South Wales is just like a state in here in Australia. So it has a severe impact towards the just like the mainland. Many like hectares of land being burned. There was a lot of death toll, and also a lot of homes were being destroyed. So it was the main essence, or just like the main area to focus on in order to save life, in order to save like the main heritage, the homes, and also people. So the main possible targets of bushfires are the animals, human, as you just see in the last slide, houses, building, that how they were being erupted, how they were being collapsed, the roads, forest. There was a lot of deforestation because of this bushfire, because like 70% of the region of Australia is covered with this forest. So this is just like a high time in order to have some system that should provide some just like different solutions. So the main technological limitations that we were facing here is there is no dedicated smart and automated system for bushfires. There is delay in an inaccurate result from the GPS technology. Obviously, when the telecommunication towers are being destroyed, the GPS technology wouldn't work and it wouldn't give you the right results or the right calculations. Lack of data about bushfire affected regions. So it was another technological limitation, then loss of telecommunication services due to these bushfires. As a consequence of this, there is delay in rescue services due to unavailability of the location maps, late identification of bushfires, and life losses, just like delay in the operation and rescue mission. Now, there is one question that are we even prepared to deal with the next bushfire within Australia or in any region, just like within US, there was Amazon as well. Amazon forest was gotten fire. So it is just like about different bushfires that have happened throughout the country or throughout the world as well. So there is a need for smart and automated system. So for that purpose, just like drones are the one, or UAV or drones, you can say can help save lives when disaster strikes, but only when they are smart and automated to do so. So the main contribution, just like are here, just like should we develop a rule-based verification framework, how we can maximize the main affected area coverage using these drones, also to maximize the flight time, just like battery life is a bit of constraint within this, just like if you want to patrol different region, if you want to hover around, if you want to take some data estimation, or like if you want to collect data using different sensors. So battery life for these drones are really important, and how you are going to basically portray a solution for that one is critical. And also how we can develop a mathematical model that is optimistic, that can give you the right direction, and also that can just like in terms of like path planning, how you can use different algorithms. So there were like previously optimization algorithm, now there are different meta-heuristic based algorithm, like PSO is a simple example, like particle swarm optimization. There are different others as well, like ant colony optimization, whale optimization algorithm, gray wolf optimization. So these are like a list of these algorithms that you can analyze your algorithm, and then you can compare the results as well. Now, the main research work during my PhD was to analyze different pre and post bushfire disaster assessment, just like what can we do before the disaster, just like this bushfire happen, or what we can do if the bushfire is spreaded to a wider area, how you can evacuate the main survival in real time. So the first was about UAV trajectory optimization, just like how you can optimize different trajectory of drones using these meta-heuristic based algorithms. And then the second one was using different image-based deep learning models like CNN, RCNN, YOLO, transformers in order to detect if there is a fire that has been happened, or if there are any survivals like animals, humans, any other entity that are being there, in order to evacuate them. So this was the main post-disaster assessment, and the first UAV trajectory optimization was the main pre-disaster assessment, that before the disaster happened, how the UAV or the drones would be moving from one place to another, avoiding any obstacles in their path, reaching the destination, and through deep learning models, how we can recognize if there are any animals, humans that are being survived, so that we could evacuate them in real time, and just like in less time or less computation time. That is the main essence of this research as well. So we were been using different IoT sensors. There are different, like at the back end, gateways, cloud computation, so that to process all these images or the information, because we can train our model on like millions of images, but on the real time, if we don't have a cloud, it may happen just like it would detect the images or just like the animals or human within certain time. So to avoid that thing, cloud computation is really important, and then it would be going to the control unit, so to notify any emergency or evacuation team to go there and evacuate those survivals. Uh, the first, as I mentioned about the trajectory optimization, so these were being used by, like I was using different meta-heuristic algorithms, comparing them with each other to find that how what is the best course that we can get, and on different environment, just like not only on a simple environment, but if we have different obstacle, and those obstacle are within a complex environment, a maze environment, or different other environments, so how this algorithm works and how we can achieve optimized results as well. The second one was the deep learning model, just like the post bushfire disaster assessment, where I have been going through different like literature for YOLO. So I had used YOLO V5 with different backbone, different neck, different detection algorithms, like using the hard switch algorithm instead of the RELO, that is the main, just like the generic one, and how we can like provide different precision, recall value, true positive, false positive. So these all are done within the PyCharm, and to just like visualize the main results of these algorithm and to compare them. So it was giving some promising results. All these studies have been like published within different IEEE transaction, like for IoT, also for geoscience and remote sensing letters as well. So you can go through them and just like have a read for these ones. The third part was the LoRa sensor localization, just like if we have different drones and if we want to calculate different, you can say metadata, and those metadata would give you different like values for humidity, temperature for a different scenario. So to recognize that if there is a fire that is going to be happening, or how you can evacuate, or how you can save it from being spread out as well. So there are different metadata, different messages are being shared within different neighboring UAVs that are being there. If the UAV cannot communicate directly with the control system, so how they can just like share the information between neighboring UAVs as well. So it was really important, and the main implications for this is just like, as I mentioned, that it is not only for operation in Australia, but also for different other countries like USA, Portugal, which are being deadly, like which are having these deadly bushfires, and it has a significant potential to contribute practical solutions again to facilitate any animals, humans that are being stuck in these bushfires, and also efficiency of these disaster management operations can be enhanced using these particular algorithm, and it can be used by different like bushfire recovery agencies or different emergency fire and rescue teams as well. This is some of my research work or the publications that I have been working on, and I have been able to publish these in different good venues. And currently, I'm also like verified reviewer of different IEEE transactions letters that I am been reviewing. Thank you very much for your attention. If you have any question, you may please ask.
Thank you, Dr. Zakir Qadri, for your enlightening presentation. Does any have any question or comments for Dr. Zakir before we move forward? Thank you for your kind word and participation, Dr. Qadri.
Sure. Thank you so much.